Hello everyone! Today we are going to apply what we learned about mixtures on the book. Part 1. Mixtures everywhere. Look at the pictures. In the first picture, we can see a brook. Do you remember the brook? It's smaller than the river. The brook contains water, sand, rocks, and leaves fallen from the trees. So this means that in the brook we have a mixture of these materials. Now look at the second picture. Muddy water. In this bottle, water and soil form a mixture. So water and soil mix together to form muddy water. In the third picture, we can see a soft drink. Soft drinks contain water, mineral salts, and dissolved gases. I told you yesterday that we call it carbonated water because carbon dioxide gas is dissolved in the water. So this means that soft drink is made up of more than one substance. Now look at the fruit salad. It is also a mixture. Why? Because we can see that many fruits make up this salad. Fruits like strawberries, kiwis, mangoes, oranges, and cherries. So look at the pictures and conclude. What is each of these mixtures made of? Are they all made up of one substance or many substances? Yes, they are made up of many or several substances. In the first example, we can see that the brook contains water, sand, rocks, and leaves, so there are more than one. Muddy water has both water and soil, so more than one. Soft drinks contain water, dissolved gases, salts, and sometimes they add flavors, so also many substances make up the soft drink. And finally, the fruit salad, of course, is made up from different kinds of fruits. Number 2. Indicate the aspect of muddy water. Look at the muddy water. Is it clear or it's cloudy? Cloudy means that it is not clear. So, by looking at the picture, we can see that water is not clear because it contains soil. This means that muddy water is cloudy or has a cloudy aspect, or we can say cloudy appearance. Complete with the convenient word. A mixture consists of several substances which can be solid, liquid, or gas. So you have to memorize that a mixture is not made up of one substance. It is made up of more than one substance. It could be 2, 3, or more substances. And these substances could be solid, liquid, or gas. Now part 2, homogeneous mixtures. We are going to discover now the difference between homogeneous and heterogeneous mixtures. Look at the experiment that was done. In step 1 they said, pour the same amount of water into 2 glasses A and B. Add to glass A a spoon of salt and to glass B some white vinegar. Shake the contents of each glass well. We can use a spoon to stir them. Let the 2 mixtures rest for a few minutes. In order to see the results, let us watch together the following video.
Let's take 2 beakers, A and B, filled to the same level with water. Add to beaker A a spoonful of salt and shake the contents well. Add white vinegar to beaker B and also shake the contents well. Let the 2 mixtures water salt and water vinegar stand for a few minutes. What do we notice? The constituents of each mixture are no longer visible. We can no longer distinguish them. The two mixtures are homogeneous. They are formed from a single phase. Let's look at beaker B. When two mixed liquids, water and vinegar, form a homogeneous mixture, we say that these two liquids are miscible.
After watching the video, let's solve together the following numbers. Number 1. Indicate the aspect of each of these mixtures at the end of the experiment. How did the two mixtures, which are salt and water, vinegar and water, appearing? What is their aspect? What is their appearance? At the end of the experiment, the two mixtures show a clear aspect. They looked clear. Specify if the salt and the vinegar disappeared in water. Actually, we couldn't see anymore the vinegar or the salt. But did they really disappear? No, they are still there, but they are in the water. We say that the salt dissolved and vinegar mixed with the water. Number 3. In your opinion, how can we make sure that the salt and the vinegar are still present in the water? How can I make sure that salt and vinegar didn't really disappear? Since salt and vinegar are two edible materials, which means that they are not dangerous or toxic like chemicals in the lab, we can taste these two liquids. When we taste the mixture of salt and water or the mixture of vinegar and water, we will know that salt is still present in the water but it is dissolved, and vinegar is still present in the water but they mix together to form a clear liquid. But tasting cannot be always used, especially in the lab, because we can be dealing with toxic or poisonous materials, so you cannot taste them. Part 4. Complete with the convenient word. Like water and salt or water and vinegar. What do we call water and salt or water and vinegar? They are called mixtures because we mix the water with the salt, the water with the vinegar, whose different components can no longer be distinguished, are known as homogeneous mixtures. They consist of a single phase. If you remember, at the end of the experiment, we saw two clear liquids with one phase only. So single means only one phase. This mixture is called homogeneous. Two liquids like water and vinegar, which form homogeneous mixtures consisting of a single phase, are called two miscible liquids. Miscible means that they can mix together. When any liquids mix together, we call them miscible liquids. This means that they will form homogeneous mixture with one phase only. Now what about heterogeneous mixtures? Also, we are going to perform another experiment. We will pour a certain amount of water into two glasses A and B. Add to glass A a spoon of sand and to glass B some oil. Shake the contents of each glass well and let them rest for a few minutes. Let's see in the following video what will happen.
Let's take two beakers, A and B, filled to the same level with water. Add to beaker A a spoonful of sand and shake the contents well. Add to beaker B some oil. Let the two mixtures, water, sand, and water oil stand for a few minutes. We notice that we can clearly distinguish the various constituents in each of these mixtures. The sand remains at the bottom of water in beaker A, and oil floats on top of water in beaker B. These are heterogeneous mixtures consisting of several phases. Let's observe beaker B. When two mixed liquids, water and oil, form a heterogeneous mixture, we say that these two liquids are immiscible.
So now we can answer questions 1 and 2. Number 1. Indicate the aspect of the mixture in these two glasses. Look at the pictures. Look at the sand and water. How do they look like? How do the oil and water look like? Are they clear like the salt and water or vinegar and water? No, the mixtures don't show a clear aspect, because we can see that each mixture has more than one phase. Look, here we have two phases, water and sand at the bottom. Here we have water and oil floating on the surface. Number 2. Complete with the convenient word. Mixtures like water and sand or water and oil, where at least two different components can be distinguished, are known as heterogeneous mixtures. So, sand and water, oil and water are called heterogeneous because we can distinguish more than one component. We can see the water and the sand. The sand didn't disappear. It didn't dissolve in the water like the salt. Also the oil, it didn't mix with the water like the vinegar. We can still see the oil floating on the surface. So these heterogeneous mixtures consist of several phases. In this case, we have two phases, one for water and one for sand, one for oil and one for water. Two liquids like water and oil, which form heterogeneous mixtures consisting of two phases, are called two immiscible liquids, which means that oil and water can't mix together. You saw in the video that even by mixing them, stirring them a lot, oil and water cannot mix. So they are called immiscible liquids. Miscible and immiscible are opposite words. Copy the answers on your books and study them well. Thanks for watching.